I am sharing my screen with you. So yeah, let's start our today's session. Hello everyone, I am your host Hasanul Banna Himel, currently studying in BRAC University at Bangladesh, and welcome to Calculus for AI and ML, Day 2, supported by Global AI Bootcamp, NSDC BRAC U, Dev Changemakers and TensorFlow User Group Bangladesh. So, what we are going to learn in today's session? So, in today's session, we will learn something about limits. We'll learn about the power rule used in calculus in the differentiation. Uh, yeah, Karna Ghosh.
Excuse me, are there records available for this session?
Yeah, the records will be available. I will provide you the link.
Thank you.
So, as we continue, so we will be discussing about limits, we will be discussing about power rule in differentiation, we will be discussing about the constant multiple rule, we will be discussing about sum rule, product rule, and the chain rule. So, at first, when we start, what is limit? So, if someone asks you what is a limit or how we can do or how a limit functions, according to the by definition, a limit is a fundamental concept that describes the behavior of a function as its input approaches a certain value. We all know that there are two kinds of function, right? One is a continuous function and another one is a discontinuous function. So when we have these kinds of functions, we can find we need to find some smaller values. So in that case, limit comes in our help. In their limit is helpful for us to find the accuracy for the value. So there are some key concepts of limits. There are finite limits, there are infinite limits, there are limits at infinity, and there are one-sided limits. So if I do a math, so what is the limit as x approaches 5 in the expression x square plus 2x plus 2? When we do that, if I do this here, let me do this with limit x tends to 5 and my this function x square plus 2x plus 2. Now, what happens? In this function, if I put 5 my this value in every single x, cause x is continuously reaching to the point 5, when I put this down I will be having a 5 square, cause here is x, 2 multiplied by 5, and we will be getting a 2. So my final result will be 37. So now if I show you some code examples. So we're currently coding in Google Colab. When I run the importing NumPy and Matplotlib, when we try to figure out something, there is some maybe problems. Just give me a second. Why it is showing this problem. This will show some values like this. If I share on the slide, it will show some values like this. If I this is my y-axis and this is my x-axis, it will create some curve like this. Here you can see it is going continuously, right? There is no dysfunction or there is no immediate break to that can stop this function or something like that. So this is our continuous function. Sorry for that. So what happens if we have some discontinuous function? Let's assume I have a limit and a function which is limit x tends to 1, and my function is x squared minus 1 divided by x minus 1. So in here you can see if I put 1 square minus 1 and divided by 1 minus 1, it will make no sense, right? So if I have this kind of mathematical problems, this will be my discontinuous function, or this will be my discontinuous function problems. So wait, let me run again. Yeah. So now, as you can see here, if I have the same limit here, that limit x tends to 1, and we in the above we got x squared minus 1 and divided by x minus 1. So we are defining a function. In this function we got we describe our this function here. So when we are running this with 2, what will be the our output? When we do the mathematically, it will be 2 square times 4 minus 1, it will be 3. 3 divided by 1 will be 3, right? So it is giving me a float digit 3.0. Now when I am uncommenting this one, we are doing this with 1. So 1 square minus 1, it will give me an error. It gives me an error because it doesn't make any sense. It is division by 0. Division by 0 doesn't make any sense, right? So now again, when we again run this with 0.9, it will give me another output. It is giving me a 1.9. When I am getting more close to 1, when I am doing this with 0.999, it is more closer than 0.9 to 1. When I am doing this, it is also giving me output. But when I am doing this with 1, this is not giving me any kind of output. It is saying that your equation is have error or something like that. And when we are again doing this at 1.1, it is again giving me some values, and 1.001, it is also giving me some values. When we are plotting this, why my plotting is not working? The x is not defined. I will upload the code later, updating the problems. So we also do these problems with our trigonometric functions. We have sine, cosine, tangent. We all have that. When we are doing this something with sine, we all know that in the when the sine value is 0, it gives an error. Again, when we are doing this, it will give me an error that encountered in scalar divide, it is not applicable. Sorry for that. when we're again doing this with 0 0.1, we're getting results. When we're doing with 0.001, we're again getting results. And when we're doing it minus 0 0.1, it is also giving results. So we can say that it is only unavailable when the value is 0, or also in the previous one when our value is 1, this value is unavailable. So for this one, here we have an infinite function. When we run this on the, when we got one exponential 3, we got an output of 1.025, and same goes for others. Here it is, as x is not defined, you need to put some value in x, so it is not running. If I put some values like 1 e5, it will give me some output. My bad, this is, yeah, now it will give an output. Yeah, here we have seen that 0.00025. So this was the limit, how we can do the limiting with the help of our Google Colab. Now when we are again in our slide, now let's talk about the power rule in our differentiation. We all know that when we are doing with some values, like we are doing with ddx, it is a derivation notation, and we have x to the power n. Let's assume n can be any values, any positive values, any negative values, it can be anything. So when we are derivating this, we will be getting our n comes in forward, n multiplied by our x, and our the power will be the n minus 1. So here our n will be at first come forward, it will be multiplied with our x variable, and it the power will subtract with 1. So if I do some example or show some example to you, let's assume I have a ddx of x to the power 8. So here I have an 8, our 8 is here the n, so the 8 will come forward, 8x to the power 8 minus 1. So my final output will be 8x to the power 7. So this is the power rule. When we're doing something with the power, the power comes in forward and it subtracts 1 from itself. Now what is the constant multiple rule? We sometimes we got multiple our constant with our variable. Let's assume I have an variable with some constant. Let's assume I got 7x. So when I am doing this, our the main formula will be the ddx, the constant c, and x. The constant will come forward, c, and then we will do our differentiation. So when we do for this one, ddx of 7x, our 7 comes in forward, 7 ddx of x, and we know the differentiation of x is 1, so our final output will be 7. Now when this was our the constant multiple rule, here we are doing this with a constant, so that was our constant multiple rule. Now let's do some sum rule or the addition one. The formula will be the ddx y plus w. Here the both will get access to the derivation, it will be ddx of y plus ddx of w. When we do this, let's assume we have ddx of x to the power 4 plus x to the power 9. When we do this, it will separate both ddx of x to the power 4 plus ddx of x to the power 9. When we do this, we know what is the power rule. We will be getting 4x cubed plus, and for this one we will be getting 9x to the power 8. So basically this was our sum rule, where we will be using all in differentiation. We will be doing all of this in, we will be using all of this in with code. We will be using TensorFlow, we will be using PyTorch in the next sessions. As this is only the day 2, we are not covering, we are not starting or covering all the coding problems in a single day. So today we're actually working with some basic stuffs, as this is for beginners, or this is for the newbies who are new to mathematical terms or who are new to the differentiation or calculus. This sessions is mainly organized for those people. So now let's move on to our next part, product rule. So what is a product rule? Here we know many things are multiplied together, like let's assume, at first let me write down the formula for you. ddx of w multiplies z. So here when we do this, it will divide by here, right? So at first my first variable will come at first, ddx of z, plus again the second variable will come at first, z ddxw. So this is the basic rule. So what will be our example, or how we can do that? When, let's assume we have a value, our w, let's assume it is 6x cubed, and our z is 7x to the power 4. So here let me do the differentiation for more easier. Individually let's do this. For this one it will be 3 multiplied by 6, 18 x square, and for this one 28 x cubed. So when we use the product rule of differentiation, after using this, now let's do this, ddx of wz. Here my w is 18x square and my z is 28x cubed. So my values will be, here we know at first we will be having a w is 6x cubed, 6x cubed, and the differentiation of w, my bad, the differentiation of z is 28x cubed. I multiply this with this, 28x cubed, plus again now for the z we have 7x to the power 4, 7x to the power 4, and multiplied with my 18x square, 18x square. When we multiply them, we will be getting 168 x to the power 6 plus 126 x to the power 6, and my final summation will be 294 x to the power 6. So that was our product rule. So here comes the main part, the chain rule. So when we're doing some our machine learning projects when we are doing or when we are using or training our machine learning models. Here the chain rule is used mostly, right? So when you will be using a gradient descent or you will be working with differentiation, it is mainly everywhere. It is available in every ml models. It is helpful, or it is mainly, you can say it is the bone of the differentiation or something like that. So what is mainly a chain rule? Chain rule is something like you are doing differentiation multiple times. Like if I have a function, let's assume I have x, my bad, let's assume I have a y of 8x cubed. At first, when we derive it for the first time, ddx of y, it will be my 24x squared. When we are doing this for the second time, or we can write here uh, y double bar, it will be my 48x. And when we are doing this for third time, it will be my just 48. So this is the chain rule. You are dividing, you are differentiating, deriving it more than one time, or until the final output, your desired output is found, or something like that. So that is for today's session. The outline is shared in my profile. You can find it there, and the session recording